Hi everyone, I hope you're okay, and I hope that the videos will keep uploading and helping you out. On this video guys, I'll be tackling the second question from the St. Stithians Girls College preliminary exam, which was written in the year of 2023. Please do expect a total number of 11 videos since the question paper had 11 questions in total. And that simply means each and every question will have its own video. And please guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your preliminary exam and most importantly, your final examination. So please guys, do share the video to your peers so that they may have the same edge as you. And please guys, help us grow the channel by just subscribing. Okay, first question, they want us to determine the values of p which the roots of this particular equation are not real. Are you together? They're taking us back to nature of roots, guys. Né? Remember that, guys. We use the discriminant to determine the nature of roots, whether our roots are real or non-real or not. Né? Please remember that if ever your delta is greater or equal to 0, therefore that means your roots are real. But if delta is less than 0, that simply means your roots are non-real or they are imaginary. Are you together, guys? Okay. So the roots, guys, are already described to me. So I don't have to prove that delta is negative. So I'm already told that the roots are non-real. Are you together? So I can therefore conclude that delta for that equation is just less than 0. But what is delta? Delta is just b squared minus 4ac. What is b? B is the coefficient of x, a is the coefficient of x squared, and c is whatever that does not have x. So the value of b, guys, is just 2 multiplied by 4 minus p all squared minus 4ac. A is just 1. C is just p squared. This is less than 0. I'll end up having okay, let's say this is just the 8 minus 2p all squared minus 4p squared is less than 0. And then I can simply remove the bracket now. Yeah? 8 squared is 64, and then this is negative 32p plus 4p squared minus the 4p squared on the other side. That's less than 0. These two, guys, will just subtract one another. I'll end up having 64 minus 32p is less than 0. And hence negative 32p is less than negative 64. If I divide both sides by negative 32p, by negative 32 rather, therefore the value of p will be greater than 2. Why is it greater than 2? Because whenever you divide by a negative number, the sign of the inequality has to change. So guys, we will have imaginary roots for this equation if and only if p is greater than 2. If p is greater than 2, we will have imaginary roots. Okay? Now I'm supposed to prove that this sigma over here is just equal to 1. Remember that, guys, sigma is just a Greek letter that tells us that you must add the terms. Né? So I'm just supposed to substitute over here starting from 1, and then I will end at 4. So for the first term, I'll end up having the log of k plus 1. That's 1 plus 1 over 1. That's basically 2 base 5, right? Plus, for the second term, I must just increment by 1 over there, right? So this would be the log of 2 plus 1 all over 2. That is just 3 over 2. I still have base 5. And then for the third term, do the same thing. The log of 3 plus 1, that's 4 all over 3. That's basically 4 over 3 base 5. And then plus the log of, now I'm just substituting the position of the last term. That's 4 plus 1 That's 5 all over 4 base 5. Uh, Over here, guys, I'm just adding logarithms, and there's a rule that says if you are adding logarithms, guys, log A plus log B plus log C, as long as they have the same base, guys, let's say the base is 2. As long as they have the same base, you are allowed to say log of A times B times C base 2. You are allowed to just multiply these indexes. So I'll end up having the log, there's a base of 5 over there, of 2 multiplied by 3 over 2 multiplied by 4 over 3 multiplied by 5 over 2 over 4 rather. All this will cancel with that one, this will cancel with that, and then 4 will cancel with the other 4, such that I'll be left with the log of 5 base 5. Are you together, guys? If I have log of 5 base 5, this can be rewritten as the log of 5 divided by the log of 5, and hence the answer is just equal to 1. That's how, guys, we're supposed to show without using a calculator. Okay, now I'm given an equation I'm supposed to solve. I'm given an equation I'm supposed to solve. The first thing I need to do is to remove the brackets, right? So this is just equal to log 3. Did I say remove the brackets? I'm supposed to remove the fractions. Excuse me, guys. So I'll just multiply each and every term by the LCD, or you can simply say we are cross multiplying, because we'll end up having 12 multiplied by log 8 base x. These two things are not similar, but they are almost similar. We can make them similar, guys. There is a rule that simply says if ever we have log of a base b, log of a base b, if ever you want to interchange the two, you can simply say 1 over the log of b base a. Are you together? For this to look like this, guys, I must just interchange the x and the 8. Are you together? And then I'll end up having 3 log x base 8 is equal to 12 multiplied by 1, or 12 multiplied by 1 over the log of x base 8. Are you together? This thing can just be written as 12 over. 12 over. So now, guys, my logarithms are the same. Just to eliminate a bit of confusion, please, guys, do this. Just say let log x base 8 be equal to k. You will end up having 3k being equal to 12 all over k. Are you together? And then now you can simply cross multiply over here. You'll end up having 3k squared is just equal to 12. If you divide both sides by 3, you'll find that k squared is just equal to 4, and hence k is equal to 2, or k is just equal to negative 2. You'll just insert a square root on both sides, and then the answer, the answer on the right hand side should say plus or minus. Are we together? Okay, but remember that, guys, we were not solving for k. K was just a tool to help us to get to the solution by eliminating confusions. So whenever I come across k, I'll substitute this guy over there. So this is just the log of x base k, base 8 rather, is equal to 2. Are you together? And then I'll end up having the first thing I need to do is to remove the log. But how can I do so? The 8 should become the base on the other side, and then this number will be just an exponent, and then x will just be remaining on the other side, and then x is just equal to 64, and then or the log of x base 8 is equal to negative 2. Do the same thing. X will just be equal to 8 to the power of negative 2, and then x is just equal to 1 over 64. That's how, guys, you are supposed to tackle that logarithmic equation over there. And please guys, do stay tuned. I wait for more videos. Please guys, don't forget to share the video to your peers. Don't forget to comment, suggest alternative ways on the comment. Criticism is also allowed. And please guys, help us grow the channel by just subscribing. Yeah, bye.